Okay, it's recording.
So imagine a 2x4 that's bent so that it wraps around the circumference of the Earth. Ridiculous, of course. The problem I'm going to have you estimate later is much more realistic. But so imagine a 2x4 bent so it's actually exactly the equator. There's a 2x4 on the equator going all the way around the Earth. So perfectly spherical-ish, spherical enough.
It used to be 2x4 and now it's
1.5 by 3.5, but call it 2x4. Call it 2x4. Now imagine it's elastic. So at every, say, 2 or 3 feet along that 2x4, simultaneously, in like a We Are the World, Hands Across America moment, it's jacked up so it's a foot off the Earth. Okay, so far? So it's basically just a big rubber band that just goes and gets jacked up so it's a foot off the Earth.
And this is every 2 feet?
That's not important, actually.
Okay.
How far is that? Just that it goes from this to this. The first question is, with those supports in place, how big is that 2x4 now? How long is that 2x4 now? You can figure out how long it was originally because the circumference of the Earth is roughly known. I think it's the diameter is about 4,000 miles, and you can do pi times 8,000 to get roughly 24,000 miles. So how big is it now that you pop it a foot off the ground? That's one thing to think about. Here's the next thing to think about. This is what blew my mind. Imagine knocking all of those supports out at the exact same time. What happens to the 2x4? I have no idea. So you have this ring, this hardwood ring, or metal, whatever you want it to be, a foot off the Earth all the way around, and simultaneously you knock all the supports holding it up out. What happens to it? It's not elastic. I'm saying it's not. Now it's not elastic. Now it's rigid. What happens? It just sits there, kind of orbiting around. The Earth orbits under it. It orbits around it. That was my guess. My guess is it just stays there and it just goes into orbit. Because if you think about it, it can't pull into one side. At least I'm saying it can't. I have no idea if it can or not because it doesn't exist. This 28,000 mile long 2x4 doesn't exist. But what would happen?
Why wouldn't it all just fall back onto the Earth?
Well, if it's rigid, assuming it's rigid.
Right.
But one vote is it just implodes. It can't handle that. Gravity breaks it into
No, it
millions of little
just falls
pieces.
back down, drops down the foot back to the Earth.
But how about the other side?
Well, they all go at the same place.
Right, but if it's rigid, it can't do that. I was saying imagine it's elastic
Right.
and blowing it out. I don't know. This is one of those questions to think about. The first question is one I might throw on your take-home exam. How big is the actual ring if it's 1 foot off the circumference of the Earth? That's kind of a fun little math problem. The second one, I don't know the answer to, so it's kind of unfair to give you the question without knowing that. The other one's just mathematics. You can figure that out. So we'll leave it
Get extra credit if you just ask us to ask.
I could estimate what would happen. It will blow up. All right. Speaking of estimates, give me some estimates of how long you guys thought it would take you to get from
4 minutes.
4 minutes.
3.5.
3, 2,
3.5.
2,
2 minutes.
1. Wow. We had ones, twos. We had 1.5s. Twos. We had twos. We had some twos.
And 2.5.
We had some 2.5s.
3.5.
We had threes evens.
Yep.
3 evens. 3.5s. Okay.
4.
4. I heard a 4, right? There was a 4. Was there a 4.5? Or a 5? Or a 6? Or I'm going to take this as long as I can because it didn't tell me I couldn't? No. Okay, so the 4 was the high. Let me hear some of your actuals. So for the 1, that was, tell me your name.
Sherry.
Sherry, thank you. What was your actual?
146.
146. Twos. Let me hear your guys' actuals. Ariel.
2 minutes, 7 seconds.
2
2.7.
minutes, 4 seconds.
2.4.
I had 2.25.
2.25. 2.16.
2.05.
2.05. We're recording, right? This is recording? Yes?
Yes.
Good, good. Thank you, thank you. 2.05, 2.16. Micah?
203.
And you're 2.03? Love it. Look at that. So, okay, let's keep going. 2.30s?
157.
157. And tell me your name again.
Brittany.
Brittany, thank you. That was only 2.30? Who said 3? Who said 3? Benji, go ahead.
222.
2.22.
232.
Cameron, 2.32. Anyone else? No.
250.
Madison, 250. Good, 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 good. 3.30. Took you.
You
Oh.
just wrote that number down.
I just wrote that number down.
Yeah, you just liked that number.
I like 3.30. It's a good one. 4. Did I write that one down too?
2 minutes, 26 seconds.
Oh, 2.26. That's not that was you too?
Yeah, 330.
3.30. And was somebody else at 4?
Yeah, that was me, 216.
216? Yeah, beautiful, beautiful. Thank you, thank you. So this is fine. I mean, we don't need every single lesson. We got quite a few of them up here. So what do you notice? What do you notice about the estimates versus the actuals? And I think something interesting happens right about here.
Well,
I think something interesting happens right about there.
I
Please.
think those of us who guessed more maybe haven't been down there yet.
Maybe, that's possible. That's a good statistical question.
Well, I haven't. So
Lurking
that's why I
variable.
said-
Maybe you haven't been to Metolius. You have no, I mean, I show you the map, but the map doesn't have a scale on it. At least what I showed you doesn't have a scale on it. So then you have to kind of invent a scale. Because if you've been to, say, Ochiko or Modoc, you'll know like roughly what 2/3 or half of the way is, maybe. Good. That's a possibility. Please.
Gauging the distance between both areas.
Yeah, exactly, right? It's an unknown for some folks. Even for those of you that have walked it, you might not know how, you probably never thought about it before. You just do it. He's like, oh my God, there's the stairs again. Ugh. And you go do it. Cameron?
Depending on our estimate, we may walk faster or slower to try and reach that estimate.
I shared this with, I think it was Brittany. I shared this because I was talking about my estimate when I went back to D. Wright on Saturday, the second time up. I started the clock at 8:30, put the phone in my pocket, turned the music on, and went. And it was so tempting to pull the phone out and look, don't do that, just go. And that's why I was so pleasantly surprised when I hit it at 102. Because I wasn't trying to match, like, oh my God, I gotta speed up because I just keep going. And for 4.5 hours to deny yourself that,
Some people's strides are bigger than others.
that's true. That's why I was trying to compare the estimates by the actuals. Linda brings up an exceptionally good point right now. In 244, we have something called a paired t-test, which is, a lot of times it's used. For example, you may have heard of the energy bracelet, or the power bracelet. Maybe it's called the power bracelet. It's got a trade name, I'm sure. It's a piece of rubber that's got like some kind of metal in it, and they say, you know, it makes you jump or more athletic, better, something or other. And the marketing was great. I saw the video for the marketing. There's this big dude, big ripped dude, and he gets the scrawny guy up. He's like, you jump. And the scrawny guy jumps, and he's like, now, scrawny guy, come here. Here's a power bracelet, now jump again! And then he jumps like 12 times further. And then he's like, you see, we prove it. I'm like, you haven't proved squat. What was then done by a research statistician was they got a bunch of people, and they put bracelets on all of them. But the people didn't know what kind of bracelet they got. Half of them got a power bracelet, and half of them got a very, very clever looking bracelet, looked just like one, but was filled, I believe, with sugar or something. And then they made them jump, and then they switched and made them jump again, and they put the other bracelet on, the power bracelet if they had a sugar bracelet, and the sugar bracelet if they had a power bracelet. And they did the exact same thing. So the reason I bring this up, Di, is because it doesn't matter. Suppose the first person jumps 6 feet, and then they jump 6'2". The other person jumps, say, 2 feet, and then like 2'3". It doesn't matter that this person's jumps were 3 times bigger. The difference in the jumps was about the same. And that's how we control for that, by pairing the actuals with the estimates that were given. So I'm not pairing that 146 with that 4, I'm pairing it back with this. Does that make sense? It also allows me to see patterns if there are any. Do you guys see any patterns? Why did I draw this purple line right here? What happened after the purple line, or before the purple line? Yes, Madison, you noticed that everybody up here underestimated their time. Everybody down here overestimated their time. But that kind of makes sense. That kind of makes sense. If you look at your times, 146 I think is the quickest, right? To 3:30. So we're talking about, is that 3:30, is that it, right?
Yeah.
So if we ignore the top and bottom and call them outliers, which I'm doing kind of frivolously here, they're about 2 minutes apart, not even 2 minutes apart, right? But if you throw those out and use the next ones down, what are I did, 250 and 157? These are a minute apart from each other. Your actual paces are a minute apart from each other. That's hella consistent, isn't it? Granted, it's a short distance, but look at your estimates. Your estimates are 3 minutes apart. Your estimates are much, much more varied than your actual walking paces. Pretty cool, huh? And it goes to show you how tricky estimation can be. It goes to show you how tricky it can be. Make sense? Ish? Getting there? So, there's no right answer for that, obviously, because I have no idea how fast you guys walk. That was kind of the point of the exercise. But I want you to use that in an assessment I've got right here. I do these every once in a while. They're called in-class quizzes. They're optional like everything else. So you can do it and not turn it in. I think you should do it and turn it in because it's worth 10 points. And that gets you 10 points in the bank. Okay? So I've got 2 different forms. One is a volume and one is a time. That's why I wanted to kind of do this time one right here. Peer team. I'm trying to go to that Oh, speaking of which, because of this, I have to push office hours, the start of office hours back. If anyone's planning on coming by for office hours today, I have to start them a little bit late. I'm guessing I'll be there by 1:45 instead of 12:30, just so you know. I'm gonna add, I put a note on the schedule page, I'm gonna put more office hours on Wednesday to make up for that. But I apologize if I'm a little bit late today, if anybody's coming by. If not, you can ignore the last 30 seconds of what I just said. Okay. So, in-class quiz. I encourage you to pair up with somebody else, maybe meet somebody you haven't talked to yet, work together, you both get credit for it. I like collaboration. The key on this is, I'm going to ask you a question you can't possibly know the answer to. Here are the two questions. How much water is in Crater Lake? And, well, the second one's a little bit long, but essentially, I'm a bike commuter, and I take a shower every day I come here after I ride the bike, because I don't want to come here stinky for you guys. We are now in Grandview Hall. We used to be in Pioneer. In Pioneer, I used to have to walk down to Mazama, take a shower, walk back. Now there's a shower in Grandview. How much time do I save in hours over the course of a year? This makes me happy, thinking about stuff like this. It doesn't mean I can stay in bed any longer, but at least I can save some time on the other end and maybe like eat breakfast instead of skipping it. Okay? Those are the two questions. The question has there's four things I want you to answer. The first question is, do you think the amount is closest to 1 million gallons, 1 billion, 1 trillion, 1 quadrillion gallons? Okay, so that's one thing to think about. Just circle your best guess. There's no right answer, it's what you think. And do you think the time is closest to an hour, a day, or a week? Again, circle the one that you think it is. Make sense so far? Next question, write down a seat of the pants estimate. No calculations. How much water is in Crater Lake? A lot. Give me a number in gallons. How many gallons of water? Write it down. Guess. Shoot from the hip. How much time? Write down a seat of the pants. Just guesstimate. Then the bottom part is where you have to start estimating. Number 2, these are kind of out of order. Number 2 asks for your estimation, and number 4 asks you to write down how you did it. So write down any assumptions you made about the shape of Crater Lake, about the distance. I'll leave this map up on here so you can see where Mazama and Pioneer are with respect to each other. That way you can use your time estimate that you just did. I'll also put a picture of Crater Lake up there so you can get an eyeball about that. I gave you some info about Crater Lake on here, also some information about Mazama. You see what I'm getting at here? You should not know the answer to this. I don't want you to know, and put the damn phones away. No Googling how much water's in Crater Lake. They don't know anyway. Like anybody's measured it. Cool? All right, let's pair off. Pick whoever you want, or you can work by yourself. That's totally fine too. Here we go. Just grab one and then hand it to the next group of 2. Grab one and hand. You can work in one group more than 2. It just seems like with more than 2, it starts getting a little obtrusive.
I think it would be good for us to break.
That's good. If you want to make a group bigger than 2, go for that. That's fine. Just make sure all your names are on there, right? Pair off. Pick somebody you don't know.
I don't know what's going on.
I'm going to turn the camera off, save some battery.